What if I told you that one of the most profound, most ancient questions our species has ever asked, the question of whether we are truly alone in this vast, silent universe, might be answered not by gazing out into the unfathomable distances between the stars but by looking inward into our own cosmic backyard? For generations, our search for companionship in the cosmos has been an act of listening. We've built colossal electronic ears, radio telescopes pointed towards the heavens, straining to catch a whisper, a structured signal, a deliberate broadcast from a distant, intelligent civilization. We have scanned the skies for beacons, for anomalies, for any sign that someone else is out there, looking back at us. It's a noble and necessary quest, born from a deep-seated human need to connect. But it is a search predicated on finding life that is not only intelligent, but technological, and broadcasting in a way we can understand, across light years of empty space. It's like searching for a single specific radio station in a city of 1 billion silent radios. But what if the first life we find isn't like us at all? What if it's simple, microbial, hidden away from sight in a place we long considered hostile and barren? What if the paradigm for finding life isn't about listening for signals, but about following the water? This change in perspective has quietly revolutionized astrobiology. The grand search for intelligent aliens hasn't ended, but it is now paralleled by a more intimate, more immediate hunt, a search for our living neighbors, no matter how small. And this hunt has led us to a place that is forcing us to reconsider everything we thought we knew about where life can exist. It has led us to a tiny, unassuming moon, a mere speck of light against the majesty of the 6th planet from the sun. Imagine a place, small and unassuming, a tiny pearl orbiting a gas giant. This is Enceladus. For centuries, it was just that. Another point of light in the sky, barely perceptible even with a good telescope. Discovered in 1789 by the great astronomer William Herschel, it was catalogued, given a name from Greek mythology, and then, for the most part, largely ignored. It was too small, too far away, and presumed to be just another dead, frozen ball of ice and rock. Even our first robotic emissaries, the Voyager probes that flew through the Saturn system in the early 1980s, didn't give us much more to go on. Their cameras showed a bright, highly reflective surface, perhaps the brightest in the entire solar system, and some cratered regions alongside smoother plains. It was intriguing, suggesting some past geological activity, but it offered no hint of the spectacular secret it was hiding. Enceladus remained a curiosity, a footnote in the grand exploration of the outer solar system. It was a world wrapped in a placid-looking shell of ice, and we had no reason to believe anything more was happening there. The universe, it seemed, had far more interesting places to explore. How wrong we were. The story truly begins with the arrival of a new explorer, the Cassini spacecraft, which entered orbit around Saturn in 2004. This was a mission designed to study the giant planet, its magnificent rings, and its diverse family of moons in unprecedented detail. And in 2005, during a close flyby of Enceladus, Cassini's instruments detected something utterly baffling. The magnetometer, designed to measure magnetic fields, went haywire. It saw Saturn's magnetic field being draped and diverted around Enceladus, in a way that only happens when a celestial body has a significant atmosphere. But a tiny, low-gravity moon like Enceladus couldn't possibly hold on to an atmosphere. It was a paradox. The science teams were stumped, but they had a hunch. They turned Cassini's cameras toward the moon's south pole as it was backlit by the sun, and what they saw changed everything. There, erupting from the surface, were colossal plumes, geysers of ice and water vapor, blasting hundreds of miles out into the blackness of space. It was a stunning, beautiful, and world-altering discovery. This little moon, far from the sun in the deep freeze of the outer solar system, was not dead. It was geologically active, alive in a planetary sense. The mystery of the magnetic field was solved. Cassini hadn't flown past an atmosphere, it had flown a cryovolcano. Think about that for a moment. A tiny moon, just 310 miles across, so small you could fit it comfortably between Los Angeles and San Francisco, is spewing the contents of its interior into space. These plumes are messengers, carrying a direct sample from a place we could have never hoped to reach otherwise. And as Cassini made more passes, flying directly through these plumes, its instruments began to read the message. The first ingredient it found was, of course, water. But it wasn't just pure water. The instruments detected salt, specifically sodium chloride, table salt. This was a crucial clue. It meant the water wasn't just a pocket of melted ice. It had been in contact with a rocky core for a long time, long enough to dissolve minerals, just like Earth's oceans. This wasn't a pond, it was a sea. But how could a vast liquid ocean exist so far from the sun's warmth? The answer lies in the immense power of Saturn. As Enceladus orbits the gas giant, its path is not a perfect circle. It is constantly pulled and pushed by the gravity of its neighboring moons, especially the larger moon Dione. This forces it into a slightly elliptical orbit. As it gets closer to Saturn, the planet's gravity stretches it into an oblong shape. As it moves farther away, it relaxes back into a sphere. This constant flexing, this planetary-scale squeezing and stretching generates immense friction and heat deep within Enceladus's core. This process, called tidal heating, is a relentless internal engine that has kept the moon's interior warm enough to sustain a liquid ocean for potentially billions of years. The discoveries kept coming, each one more exciting than the last. Cassini's instruments detected simple organic molecules like methane, and then more complex ones. The kinds of carbon-based molecules that are the fundamental building blocks of life as we know it. The raw materials were there, then came the true bombshell. Deep within the plume data, scientists found evidence of tiny nanoscale grains of silica. On Earth, silica nanoparticles like these are formed in only one specific environment, hydrothermal vents. Deep on our own ocean floors, where seawater seeps into cracks in the planet's crust, gets superheated by magma, and is then expelled back into the ocean in chemical-rich black smokers. These vents are oases of life in the crushing dark, supporting entire ecosystems that thrive not on sunlight, but on chemical energy. The presence of silica in the plumes of Enceladus was the strongest evidence yet that similar hydrothermal vents exist on the floor of its hidden ocean, providing a powerful source of energy and chemistry. So let's assemble the pieces. We have a vast global ocean of liquid salt water that has likely existed for eons. We have a powerful energy source, both from tidal heating and from what appear to be Earth-like hydrothermal vents on the sea floor. And we have a rich soup of complex organic molecules, the very stuff life is made of: liquid water, essential elements, a source of energy, and organic compounds. This is the complete checklist, the recipe for life as we know it. Every single ingredient has been found in this tiny, once-ignored moon of Saturn. This isn't science fiction, this is the story of Enceladus, a story that continues to unfold today. And on this day, September 26, 2025, the final analysis from years of sifting through Cassini's legacy data has been confirmed. The latest findings, published this morning, have identified traces of phosphorus compounds within the ice grains, the final crucial element needed for DNA and cell membranes. The entire recipe is complete. The question is no longer whether Enceladus support life. The question now is whether these plumes are messengers, offering us a tantalizing glimpse into a hidden habitable world. They are an open invitation, a challenge etched in ice, daring us to come back, to look closer, and to finally answer that profound ancient question.